Okay, this is a whiteboard. Let's discuss some things regarding reflection coefficient, regarding some basic. Okay, let's say this is a pitch of transmission line. This is called a pitch. TL means transmission line, a pitch of transmission line. What are these? This is the input, this is the load. That means this is the source. This is source, this is load. Source and load, right? These are source and load. And here, this is Z0. Impedance of this line, this portion is Z0. And this is the ZL. Z0 is called the characteristics impedance. Characteristics impedance. Z0 is called the characteristics impedance. Okay. So this is the characteristics impedance. And here, Z0 is characteristic impedance. So this is source, a pitch of transmission line, and this is called the input impedance. Sorry, this is the there are two kind of wave. One is incident wave, or what I would say V plus. One is reflected wave, that is the V minus. V plus, we are assuming that this is the incident wave. Incident wave. And this is reflected wave. This is reflected wave. V minus is reflected wave. And this is transmitted wave. VL. Incident, reflected, transmitted. Three kind of waves are there. Okay, incident wave, reflected wave, and transmitted wave. And from this we can find out some equations like this is ZL, this is source. Okay, and we found a wave that is the standing wave. This wave is called a standing wave. How it happens? This happens when we merge these two. Whenever we merge these two waves, then we'll get the incident wave. Sorry, then we'll get the standing wave. This is called the standing wave. This kind of wave is called the standing wave. This kind of wave is called the standing wave. Okay, standing wave. That is the V mean. This is V mean. This is V max. This is V max. This is V mean. Okay, V max. That is the maximum amplitude. So how we get it? When this is incident wave, and we get the reflected wave. Okay, incident and reflected wave combination gives this kind of wave. Okay, so these two. So if we draw in different manner, like see, let's say okay, so this wave combination of these two will give this kind of wave. So that is called the standing wave, and from the standing wave ratio we'll get the new thing, that is S, or it's S. S is equal to VSWR, which is voltage standing wave ratio. You can write like this: V max divided by V min. V max by V min.
Sir, again here.
S is the voltage standing wave ratio. VSWR. VSWR means the voltage standing wave ratio. VSWR is equal to S, and S is equal to V max by V min. V max by V min. S is equal to V max by V min. Okay. S is equal to V max by V min. And there are some other equations like reflection coefficient and transmission coefficient. Some equations are there. One equation is reflection coefficient. Let me write this. Alright, let's write some equations. Reflection coefficient is rho. Rho is equal to ZL minus Z naught divided by ZL plus Z naught. That is rho. Or sometimes they call it capital gamma. Anyone, either capital gamma or the rho. This is called the reflection coefficient. Reflection coefficient. This is called the reflection coefficient. Okay, ZL minus Z naught divided by ZL plus Z naught. That is called the reflection coefficient. Okay, and S is equal to V max by V min. This is the VSWR, and deflection coefficient is equal to ZS minus Z0 divided by ZL plus Z0. And we have another value, that is S. For the S, we can write S equal to 1 plus rho by 1 minus rho. Is it okay? The equation 1 plus rho divided by 1 minus rho. That is equation of S. Okay. So these equations will be required when you do the math. So let's do a math. Okay, let's have a math. Let's have a math. A simple problem. Let's say let's say okay, let's move on the book. Okay, I'm opening the book. Just a minute. Let's open the book here. Okay, let me share one thing, one chapter. Okay, this is chapter 1, from which I am trying to solve few things. Okay, see, standing wave ratio. Standing wave ratio is equal to V max by V min, or we can say 1 plus rho divided by 1 minus rho. Similarly, for rho, we can write S minus 1 divided by S plus 1. Do you know how it comes? Let's say S plus 1 divided by S minus 1. addition subtraction. So what will happen? 1 plus row plus 1, 1 minus row minus 1. Oh no. No, let's say write this equation. 1 plus row divided by 1 minus row. Now 1 plus s, 1 minus s. Let me draw it on the whiteboard. Let's move on to the whiteboard. Oh, just do it here. Let's do it here. Say from here is plus 1 by s minus 1. So 1 plus row plus 1 minus row, 1 plus row minus 1 plus row. So what would happen? Here s plus 1 by s minus 1 is equal to, see, 2, here 2, here 2 row. So 2 would be cancelled out. That would be 1 by row. So row would be s minus 1 divided by s plus 1. That is the derivation of this line. Derivation of this. So rho is equal to s minus 1 divided by s plus 1. It comes from here. Okay, you understand? Is it clear to you?
Yes, sir, it's clear.
Okay, very good. Okay, now, so the maximum impedance would be Z naught into S, and minimum impedance would be Z naught by S. This is the formula. Let's do the math from here. Let's see. An impedance of 100 plus J 100 ohms is placed as a load on the transmission line of characteristic impedance 50 ohms. Find the reflection coefficient in magnitude and phase and the standing wave ratio for the line. So can you solve it? I think you can solve it. First one, first problem. So in this kind of problem, first you have to draw the line. This is the transmission line. This is the load. ZL is equal to 100 plus J 100. 100 plus J of 100. ZL. Z naught Z naught is equal to 50 ohms. Z naught is equal to 50 ohms. Find the reflection coefficient in magnitude and phase and the standing wave ratio for the line. So we can find out the rho equal to what? ZL minus Z naught divided by ZL plus Z naught. So put the values here. 100 plus J100 is the ZL minus Z naught means the 50. And ZL 100 plus J100 plus 50. So it would be 50 plus 100 J of 100 divided by 150 plus J of 100. Now do the calculation. What would be the value? Actually, this is something like that. Phase, if you look at the phase, r theta. Okay, so if you find it, do the calculation, use your calculator, then you'll get it. Use the calculator. R theta, R angle of theta. What is the value of R? Do you know? What is the value of R? Just do the calculation, then you'll get it. Then the second part is standing wave ratio. So you've got the rho. Can you calculate what is the value? Anyone, please? Just calculate and give me the value. Omar Murasi, Sakline. Anyone do the calculation and give me the result. Mark.
Sir,
Yes.
50 plus J100 উপরেরটা স্যার।
হ্যাঁ 50 প্লাস J100 আর নিচেটা হচ্ছে 150 প্লাস J100। দেখো তো কত আসে।
0.03 maybe, sir.
I need the result, then I will show you another tricks. I do not have the calculator right now with me. Can you please check?
150 plus স্যার ফার্স্ট আছে হলো 50.3330
অ্যাঙ্গেল
আই এর ভ্যালু আসে হলো স্যার প্লাস স্যার, প্লাস পরে আই এর ভ্যালু আসতেছে 0.64 আই। সেটা কি জানি পোলারে নিচ্ছি আমি।
then I need this type of value, that means the polar.
স্যার অ্যাঙ্গেল আসে 0.52 আর 50 পয়েন্ট, ওইটা ঠিকই আছে, 50.03 আছে আর অ্যাঙ্গেল আসে 0.52।
অ্যাঙ্গেল আসে কত?
0.52।
0.52. Okay, so here we have got this value. This is the magnitude 50.03, whatever it is, 50, round 50. That is the magnitude. So whenever you find the S is equal to 1 plus rho divided by 1 minus rho. That means you have to take the magnitude of this value. 1 plus rho means what? Rho plus 1 or rho minus 1?
অনলি ম্যাগনিটিউড স্যার।
Yes, we are taking the only magnitude.
ওকে স্যার।
Okay, we are taking only the magnitude. See here. See 1 plus rho divided by 1 minus rho. এই তোমার এখানে ভুল হয়েছে। এই ঠিক আছে এটা।
জি স্যার।
It's okay, sir.
It's okay. So just add
Yes,
this
sir.
one. Say, but the thing is, it should be positive. Range of S is 1 to infinity. So here it would be negative. It shouldn't be negative. It should not be negative. It is positive. The range would be 1 to infinity. So I think you have done mistake here. Okay. Just check this out. Or just a minute, I bring out my calculator. this series. This is the scientific calculator. So where is the values? Where is I? For complex. Okay. What is the value we have? We have the value 50 plus j 100. 50 plus 100 I. Okay. Divided by, let's have a 150 plus 100 I. Say that is the value 0.53. 0.53 plus 0.307 I. Okay, so you are wrong. Now convert it to the polar. So how to convert it here? I don't know how to convert it here. In this kind of calculator. Okay, now Sakline এটা চেক করো তো 0.53 আর হচ্ছে 0.307 I think it would be 0.53. Then the value would be positive. Your mistake was, I think, in the bracket. You do the wrong bracket, give the wrong bracket. So the value would be 0.53.
স্যার 0.06
আবার ঠিক মতো করছো তো?
জি স্যার, আপনারটাই করছি স্যার। ম্যাগনিটিউড আসছে 0.06।
0.06.
জি স্যার।
অ্যাঙ্গেল
আসছে 23.98, মানে 30 ডিগ্রি অ্যাঙ্গেল। 98.98।
23.8. Now you can find out the S. 1 plus 0.06, 1 minus 0.06.
স্যার
So
উপরে তো 50, তারপর 150 ছিল, ওইটার জন্য এরকম হয়েছে। নিচেরটা 150 দিয়ে করছি, এটা ভাগ করে করছিলাম।
হ্যাঁ
এটা বড় আসছে মানটা।
So it would be, এখন কত দাও তো? আসলে তো খেলা আছে আবার।
জি স্যার।
আসলে আবার খেলা আছে না, বাংলাদেশ খেলতে নামছে।
জি স্যার।
বোলিং এ।
আমি নিউজ দেখিনি। ওইটা আসছে স্যার, ভাগ করার পর আসছে 0.12।
0.12.
জি স্যার।
Wrong. It is wrong, I think. Because value should be 1 to infinity.
স্যার আপনি তো ভাগ করেন না স্যার।
One. It is only one, sir.
How 1?
Sir,
1
it will
plus
be,
0.06,
sir,
sir. Divided by 1 minus. It will be 1.
1.06 divided by 1 minus that would be 0.94.
sir, 0.6, sir.
It is 0.6 or 0.6. I think you guys are doing wrong.
Sir, the upper part is 1 plus
Sir,
0.
1.12, sir. 1.12. 1.12, sir. জি স্যার 1.12
সেটাই তো বলতেছি।
জিরোটা না, জিরোটা উঠে 12। জি স্যার ঠিক আছে এখন।
If it is 1.12, that's okay. Because the range should be 1 to infinity. Okay, see. So here what you have learned, that if you do not operate the calculator properly, then it will give the wrong answer. You understand? So how to use
Yes.
calculator? Say upper part 50 plus j of 100. J of 100, use the bracket here. Otherwise, it will give the wrong answer. 150 plus j of 100. Okay. Then check it becomes 0.53 plus j of 0.307. 307 or 308, whatever. Then convert it to the polar. So what is the formula? Polar formula? Do you remember what is the R and what is the angle formula?
Radiation
Yeah.
to angle, sir.
Okay, like this. Like this. Okay. I think it would be 1. I think 0.53 and something. But I do not know. I have not found my calculator. I do not know where I kept. Then I will check. Okay, so that is the way to calculate this kind of thing. Okay. And some other problems are there. And one thing, a standing wave. Ideal line with applied sinusoidal voltage. These are the equations. Equations for reflection coefficient and equation for transmission coefficient. Okay, let's do another problem. This is the ideal transmission line. One-dimensional wave equation. Let's bring out the one-dimensional wave equation for the ideal transmission line. Let's consider a transmission line here. This is a transmission line, and let's consider a small zone, small length, which is dz, small length of transmission line, which is dz, and here is the voltage drop. Voltage drop at the left is V, and at the right is V plus del V del Z dz, and current has also been changed because because of the length the dz. Okay, so voltage change can be written as del V del Z dz, or is equal to minus L dz del I del t. And current change can be written like this. From these two, we can reduce the dz. We can cancel out the dz. See, from these two we can cancel out dz. So it would be like this: del v del z is equal to minus L del I del t del and del A del Z is equal to minus C del V del T. Okay, length dz may be cancelled out. So length dz may be cancelled out. These are the 3 and 4. Now if you do the calculation, do the differentiation for this line, then you'll get this with respect to what? The first one with respect to del z, and the second one, okay, like this, just del z del z. Okay, just do this, then you will get the value. This kind of result. Okay, this kind of result. Then finally put this value. So since partial derivatives are the same taken in either order, so 6 may be, so we can write the 6. Instead of 6 we can write what? This value del square del t del z. Instead of this we can write this one in the 6. Put the 6 into the equation, put this 6 into equation 5, then you will get this kind of equation. Okay, so equation 3, 4 are known as the telegraphist equation. The equation 7 is the one-dimensional wave equation. 7 is the one-dimensional wave equation. It is called the one-dimensional wave equation. Similar equation can be found for the eye. 8. So 7 and 8, those are known as the one-dimensional wave equation. Okay, 7 and 8 known as the one-dimensional wave equation. Okay. So this is the one-dimensional wave equation. So simple one. You check this out. I think you will be able to understand. So that's how you can solve it. And another one is there. This one, the ideal line with applied sinusoidal voltage. So applied sinusoidal voltage, this is called the input impedance, and that is the input admittance. Two equations are there. These equations will also be required for the math, for the maths. Zi is equal to z naught, this, gamma I is equal to gamma naught, this. Okay, so these are the equations, input impedance equation and input admittance equations. Okay, so you can solve this for the maths, and I think some maths are there here. See, these are the problems. Some equations are there, some problems are there. and standing wave ratio problems. You can check these problems at your home. So I think these things are for today. We'll check few more maths from tomorrow, inshallah. Some maths will be there, and you have to solve those maths by yourself or by or I'll show you, inshallah, other maths.
Okay, sir.
So now give me the attendance. Take snapshot and give me the attendance in the
last
messenger.
class, which time you touch?
What?
Lab class, sir.
Lab class.
Yes.
Today's lab, right?
Yes, sir.
Yeah, in the lab section, I can show you only the equipment, nothing else, because it is hardware based.
Sir, can we go to the lab class in offline?
I have to request Basis sir. Okay, is it possible or not? Okay, I will talk with him and I'll let you know. I think in the next week,
Inshallah.
in the Saturday, inshallah, I'll go to the campus and I'll do some video for you. Okay, live video,
Inshallah, sir.
inshallah.
Sir.
Okay, so it's okay for today.
Hello, sir. Hello.
Yes.
Sir, please share this lecture, sir. Transcription on today's lecture.